you do not learn anything else in this class, I really think you need to learn about polynomials and factoring. Okay, what I'm going to do is actually read all of these little words, but we're going to talk about what it means in English. Polynomials are algebraic expressions that meet further criteria. These criteria are that each term in a polynomial consists only of a number multiplied, if it is multiplied by anything at all, by variables raised to positive integer exponents. Okay, what does that mean? Each term, okay, this would be considered a polynomial, something like 4x squared y minus 3x plus 2xy. It can keep going, but we'll just stop right there. This is considered a polynomial. Each term, these are all terms. Let me add one more thing, plus 4. Okay, all of these are considered terms. It says, if it is multiplied by anything at all, by variables raised to positive integer exponents. That means these variables are multiplied, and each of their exponents are integers. This one has an exponent of 2, this one has an exponent of 1, so on and so forth. The number in each term is called the coefficient of the term. So that would be the 4, the 3, the 2, the 4. Those are all considered the coefficients. And the sum of the exponents of the variables is the degree of the term. So for this term, the degree would be 2 plus 1, this little 1 that you can't see. So the degree of this first term would be 3. The degree of the second term would be 1, because that's a 1 right there. Both of these variables have an exponent of 1, so the degree of this term is 2. If a given term consists only of a non-zero number, this is a non-zero number. It consists only of this number. Its degree is defined to be 0. For example, if you did put a variable on there and you put a little 0 up there, x to the 0 power is actually just 1. 4 times 1 is 4. So that's why the degree of this term is 0. The polynomial as a whole is also given a degree. The degree of the polynomial is the largest of the degrees of the individual terms. Okay, let's talk about these degrees of the terms again. The degree of the first term is 3. The degree of the second term is 1. The degree of the third term is 2. And the degree of the fourth term is 0. So the degree of this entire polynomial is the largest of those degrees. So the degree of the polynomial is actually 3. Every polynomial consists of some finite number of terms. That just means you have a set number. It doesn't go on and on forever and ever. This particular polynomial has 4 terms. Polynomials consisting of a single term are called monomials. So if you had only had 4x squared y, that would be considered a monomial. If it had 2 terms, so if it stopped here at this minus 3x, it stopped right there, then that would be called a binomial. And if it has 3 terms, it's called a trinomial. A polynomial in the variable x of degree n can be written in this form. A sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a whole bunch of stuff plus a sub 1x plus a sub 0. What in the world does that mean? Where all of these a sub somethings are real numbers, so that just means all these little a's are real numbers. Kind of like up here, the 4, the negative 3, the 2, and the 4. Those are all real numbers. And n, n minus 1, n minus 2. So all of these little n's right here, all of those are whole numbers. Whole numbers mean they're either 0 or positive. If you remember when we talked about the real number system, these are all considered real numbers. For example, this number, all of these little exponents, these have to be real. So they have to be whole, not just real. They have to be whole numbers. This form is called descending orders because the powers descend from left to right. The leading coefficient of this polynomial is a sub n. So if this had been written with these two terms switched, then it would be written in descending order because the degree would go 3, 2, 1, 0. The leading coefficient of this particular polynomial is 4. So whenever you're trying to add or subtract polynomials, what you have to remember is you simply combine like terms. However, if you have a minus like this one, it's like having a minus 1 sitting right there. So what you need to do is distribute that negative 1 before you do anything else. So let's have a look at A. The first parentheses, nothing really changes because there's no negative in front of it. So 7x squared minus 2xy plus 3y squared. Now we need to distribute this negative. So negative 1 times negative 3x squared is positive 3x squared. Negative 1 times negative 2xy is positive 2xy. And negative 1 times 5y squared is negative 5y squared. Now you just go through and combine all your like terms. 7x squared is like 3x squared because their variable parts are the same. 7 plus 3 will give us 10. Okay, then we have a negative 2xy and a positive 2xy. Well, negative 2 plus 2 is 0, so those just go away. And then we have 3y squared minus 5y squared. When you combine 3 and negative 5, you get negative 2y squared. This is the answer. Okay, for B, we have a plus here. If you were to distribute a plus, nothing changes. So really all you have to do is combine all your like terms. So does 12ab cubed c have a like term? Oh, here's a minus ab cubed c. The ab cubed c is the same. That means these two are like terms. So 12 minus 1 gives us 11 a b cubed c. Okay, so now we have to look at the next term. 8b to the 5th c squared. Does it have a like term? It does not, so we just bring it down. Plus 8b to the 5th c squared. Okay, so this one is finished. Now we have an ac cubed. Here's an ac cubed, so we need to combine these two. Negative 3 plus 5 will be a positive 2 ac cubed. And then all we have left are the constants. We have a negative 10 and a positive 4. So negative 10 plus 4 is negative 6. Now you're supposed to make sure this is in descending order. So just to keep everything in the right order, let's go ahead and look at the degrees. The degree of this term is 3 plus 1 plus 1. This will be 5. This will be 7. This will be 4, and this will be 0. So the 8b to the 5th c squared would go first. That was degree 7. This would be degree 5, so a positive 11a b cubed c, and then degree 4, and then degree 0, plus 2 ac cubed minus 6. It's a really big, ugly answer, but that is the answer. Now we're going to be multiplying polynomials. This is where you just take everything in the first parentheses and distribute it to everything in the second parentheses. So let me just recopy this so we can see what's going on. I'm probably going to run out of room, but we'll work with it as we get there. Okay, so we're going to distribute the 4ac. So 4ac times 3ac is 12a squared c squared. 4ac times 2ab cubed, that will give us 8a squared b cubed c. I like to put my variables in alphabetical order. So 4ac times negative abc is negative 4a squared b c squared. Okay, now we distribute everything, the negative 6ab to everything in the second parentheses. So negative 6ab times 3ac. Let's look at what our variable part will be. A squared bc. Do we have one of those? A squared, we do right here. No we don't. Okay, so we need a new term. So minus 18 a squared bc. Okay, negative 6ab times 2ab cubed would be a negative 12 and then a squared b to the fourth. Okay, and then we have negative 6ab times negative abc. That'll be a squared b squared c. So negative times negative is positive. 6a squared b squared c. The next thing you need to do is make sure you don't have any like terms. I think I double checked that as we went through, but just in case, I'll have one more look. Oh, that's it. So if I could squeeze all of that in one line, that would be my answer. Okay, so how about B? Think we can squeeze that in here? Let's see, we have xy plus 2y times 2xy plus 5y. Okay, we're going to multiply xy times 2xy. That'll give me 2x squared y squared. Xy times 5y is 5xy squared. 2y times 2xy is 4xy squared. And then 2y times 5y is 10y squared. Okay, this time we do have some like terms. These two are alike. When you combine those, we end up with 2x squared y squared plus 5 plus 4 will give us 9xy squared, and then plus 10y squared.